You know, uh, it feels like the entire tech world is just buzzing about these large language models, right? These LLMs.
Absolutely.
And this like fundamental question, how do we actually get them to do what we want?
Yeah, exactly. Which is where this whole field of prompt engineering comes in. It's blowing up.
It really is becoming essential kind of overnight.
Yeah.
And speaking of essential, you've probably heard the chatter. Google dropped this pretty hefty white paper on it.
That's the one. It's really taken off.
Mm-hmm.
So for this deep dive, yeah, we're focusing squarely on that paper by Lee Boonstra. It's called Prompt Engineering, all 69 pages of it.
Wow, 69 pages.
Yeah, and it's clearly hit a nerve. You see it referenced everywhere now. It's become a go-to resource if you're serious about working with LLMs.
Right. So for everyone listening, our mission today, basically, is to wade through this thing
hmm
and pull out the really important stuff, the fascinating insights, make it, easy to grasp and something you could use right away.
Like the express lane to understanding the paper.
Exactly. Without needing, hours and hours to read the whole thing yourself.
And what's great about this paper is just how much ground it covers. It really touches on all the key bits.
Like what specifically?
Well, you've got the basic core prompting techniques, right? Then it gets into more advanced strategies for the trickier problems,
Okay.
plus a whole section on code generation, which is huge.
Oh, yeah.
And then best practices, like how to actually do this well, and even a look at where things might be heading, future trends.
Okay, let's unpack that. So when we're trying to, talk to these models,
Yep.
where's the starting point? How do we begin?
Right, so the paper lays out these fundamental building blocks first. Think of them as your basic toolkit.
Okay.
First up is zero-shot prompting. Simple idea. You just give the LLM an instruction or ask a question. No examples.
Oh,
You're basically banking on its pre-trained knowledge, all that data it learned from. You're hoping it's enough to figure out what you mean.
so just summarize this text
Mm,
and cross your fingers.
pretty much. It shows off how much these models know, generally speaking, but it has limits, especially if the task is a bit weird or specific.
Yeah, I could see that if it hasn't seen something quite like it before. Okay, so that's zero shot. What's the next tool?
Next, you move into one-shot and few-shot prompting. This is where you start giving it examples.
Okay, like hints.
Exactly. One shot means you give it just one example. Show it the kind of input and the kind of output you're looking for.
Right.
Few shot just means giving it more examples. The paper suggests usually around 3 to 5 is a good rule of thumb.
Ah, okay, so you're really clarifying the task, showing it the pattern you want.
Spot on. It's like showing your work, like you said. You're
Yeah.
not just asking for the answer, you're showing it how to get there, or at least what the destination looks like.
And the paper says these examples are really key for guiding the structure of the output. Yeah.
Precisely. And not just structure. It makes a good point about including edge cases in your examples.
Edge cases, like weird inputs.
Yeah, unusual stuff. If you show it how to handle those tricky bits in the examples, it makes the model more robust overall, better at handling unexpected things later.
That's smart. So if you're teaching it about pizza orders, don't just show pepperoni. Show it like a half and half or one with anchovies and pineapple.
Exactly. Though maybe not anchovies and pineapple, but yeah, the principle holds, show the variety.
Okay, got it.
And the paper does mention, while 3 to 5 examples is a good starting point for few shot,
Uh-huh.
the ideal number isn't fixed. It can depend on how complex the task is, how good your examples are, even like the model's input length limits.
Right. Practical constraints. Okay, so zero shot, one shot, few shot, any other basic techniques?
Yeah, the next couple are more about setting the scene, the overall context for the model.
Setting the stage.
Kind of, there's system prompting. This is where you give it overarching rules or define the main goal for the whole conversation, the big picture.
So telling it its main job.
Right.
Like you are a helpful translator.
That's a perfect example, yeah. It sets the overall behavior.
Okay.
Then, sort of related, is role prompting. Here, you actually assign the LLM a specific persona.
Oh, like telling it to act like a specific person or job.
Exactly, like act as a book editor or respond like a kindergarten teacher.
Huh. I can see how that would totally change the output.
Mm.
A kindergarten teacher explaining quantum physics would be interesting.
Definitely different from a physics professor. The paper mentions a motivational speaker, too. Each role changes the tone, the style, the kind of knowledge it focuses on.
Cool.
And the last basic one is contextual prompting. This is just about feeding it the necessary background info for the task at hand.
Makes sense. Give it the facts it needs.
Right. The more relevant context you provide, the better it understands the nuances and hopefully the more accurate the results.
So if I'm asking about, I don't know, a specific battle in history, I should give it the dates, the key players.
Precisely. Give it the setup. It all boils down to giving the LLM the best possible starting point to understand your request.
Okay, these core techniques sound super useful. But what about when things get, more complicated?
Yeah. That's where the paper really gets into the advanced stuff. Strategies for those trickier, more complex tasks.
This is the really interesting part, I think. Where do we start with the advanced strategies?
Well, a big one they focus on is chain of thought prompting. COTI for short.
Chain of thought. Okay.
It's a really clever technique. You basically guide the model to think through a problem step by step, make it explain its reasoning as it goes.
Oh, I think I've seen this. Like adding, let's think step by step to the prompt.
Exactly like that. It works surprisingly well, especially for things like math problems or logic puzzles, where just asking for the answer often fails.
Right.
And the beauty is, the paper says it's relatively low effort to implement. You don't need special model fine-tuning. Works with off-the-shelf LLMs.
Nice.
Plus, you get interpretability. You can see the model's thought process.
Which is huge for figuring out where it went wrong if it makes a mistake.
Totally. Helps with debugging. And the paper suggests it might even make your prompts work better across different LLM versions. More robust.
Okay, sounds incredibly useful. Are there downsides? Any trade-offs?
Well, yeah, because it's generating all those intermediate reasoning steps. The output is longer, more tokens,
Which means,
potentially higher costs if you're paying per token, and it takes longer to get the answer, more processing time.
okay. Cost and speed. Makes sense.
The paper uses a classic age riddle example, actually, you know the type, where a direct prompt usually gets it wrong,
Yeah.
but with chain of thought, breaking it down, it can often arrive at the correct solution. So it's that trade-off.
Yeah.
Do you need the accuracy enough to justify the extra tokens?
Right, a key decision point. Okay, so COTI for complex reasoning. What other advanced tricks are in the paper?
The next big one is called REACT. Stands for reason plus act.
Reason and act. Okay.
This takes it a step further.
Yeah.
It combines that internal reasoning, like COTI, with the ability to use external tools.
External tools. Like
Yeah.
what?
Like giving the LLM access to a search engine or a calculator or even a code interpreter.
Whoa, so it's not just thinking inside its own brain. It can actually go out and do things, look things up, run code.
That's the idea.
Yeah.
The paper calls it a thought action loop.
Okay.
The LLM thinks about the problem, figures out an action it needs to take, like doing a search, uses the tool, gets the result, observes it, and then uses that new information to update its thinking and plan the next step.
Wow, that sounds remarkably human, like how we solve problems. Think, try something, see what happens, adjust.
Exactly. It's trying to mimic that process.
The paper had an example, didn't it? Something about Metallica.
Yeah, finding out how many children the members of Metallica have combined.
Right. How did React handle that?
Well, it figured out, okay, first I need to know who is in Metallica. So action, search for Metallica members, gets the list. Then it thinks, okay, now I need to find out how many kids each of these guys has. So action, search for James Hetfield children, then Lars Ulrich children, and so on. Gets those numbers, then finally action. Add them all up. Or rather, it reasons that it needs to add them up and provides the final sum.
That's seriously impressive. Does it require special setup?
Yeah, the paper notes you usually need to keep feeding the conversation history back in to maintain context. And you need good examples or instructions to guide that thought action process. It needs to know how to use the tools effectively.
Got it. So COTI is internal reasoning, React adds external actions. What else did they mention in the advanced section?
They briefly touched on a few others. There's tree of thoughts, or TOTI.
Tree of thoughts.
Yeah, it's kind of like COTI, but instead of just one line of reasoning, it explores multiple possible reasoning paths at the same time, like branches of a tree.
Okay, exploring different options.
Right. Then there's self-consistency voting. This one's interesting. You prompt the same question multiple times, maybe tweaking the temperature settings slightly.
Temperature. You mentioned that before. That controls randomness.
Exactly. Higher temperature means more creative, maybe more varied answers. So you get a bunch of different answers to the same question, and then you just pick the answer that shows up most often, the most consistent one.
Like wisdom of the crowd, but the crowd is just the LLM run multiple times.
Kind of, yeah. The idea is the most frequent answer is probably the most reliable. But again, the paper points out it costs more because you're running the prompt many times.
Right, more tokens, more compute. Okay, what was the other one? Step back prompting.
Yes, step back. This one's quite clever. The idea is to get the LLM to activate relevant background knowledge before tackling the specific question.
How does that work?
You first ask it a more general question related to your main task.
Okay.
Then you take the answer it gives to that general question, and you include that information in the prompt when you ask your actual specific question.
So, like priming the pump.
Hmm.
Getting it thinking along the right lines first.
Exactly. Zoom out, get the general context, then zoom back in on the specifics.
The paper had an example about a video game storyline.
It did. Like before asking it to write a storyline for a specific first-person shooter game,
Yeah.
you first ask it, what are common themes in engaging FPS game storylines? Then you use those themes, it identifies as input or context when you ask it to write your specific storyline.
Ah, I see. So it leverages that general knowledge to improve the specific output. Clever.
Yeah, the claim is it can really boost the quality and accuracy.
Okay, wow. So we've got the basics and now these really powerful advanced techniques. The paper also talked about code generation, right? That's a huge area.
Massive. Yeah, the paper definitely highlights how prompt engineering is transforming software development. LLMs are becoming serious tools for coders.
In what ways?
Well, the most obvious one is code generation. You can literally just ask the model, write me a Python function that does X, or generate the code for a quicksort algorithm in Java.
And it just writes the code.
Often, yeah. You describe what you need, specify the language, and it spits out functional code. The paper shows an example of generating a Python quicksort function.
That's amazing. Just describe it and boom, code. What else?
Well, related to that is code explanation. This is super useful. You can feed it a chunk of code, maybe something complex or old, and ask it, explain this code line by line, and it will break it down, telling you what each part does. Great for understanding legacy code or learning new languages.
Yeah, I can see that being incredibly helpful, like having a patient tutor.
Totally. Then there's automated testing. You can prompt the LLM to generate unit tests for your code.
Seriously, it can write tests too.
Yep. Helps ensure your code actually works correctly and catches bugs early. Helps with quality assurance.
So writes the code, explains the code, and tests the code. What else is left?
Well, it can also help with code optimization. You can give it your code and ask, can you make this faster? Or suggest a more efficient way to do this.
Okay, so performance improvements too.
Right. And the last big one they mention is documentation generation.
Ah, the bane of every developer's existence.
Exactly. You can use prompts to get the LLM to write clear, comprehensive documentation function descriptions, explaining parameters, usage examples. Huge time saver.
That alone sounds revolutionary. The paper had a detailed walkthrough using bash scripting, right, for renaming files. Can you take us through that?
Sure. It's a great example of the whole process. So first, the prompt, something like, write a bash script that takes a folder name as input and then renames all files in that folder by adding draft to the beginning of each file name.
Okay, clear instruction.
The LLM then generates the bash script, and the example in the paper includes comments explaining what the script does, which is nice.
Good practice.
Then, crucially, the paper stresses, test the code. Don't just assume it works.
Right, always test generated code.
So they show creating a test folder with some dummy files, running the generated script, and confirming that, yes, all the files now have draft prepended. It worked.
So from natural language request to working script.
Yeah.
Cool. And then they use that same script for the code explanation part.
Exactly. They took the working bash script, maybe stripped the comments out first, then fed it back to the LLM with a prompt like, explain what this bash script does.
And the LLM.
It gave a detailed breakdown. Explain the part that gets user input, the check to see if the folder exists, how it loops through the files, the actual renaming command, and the final success message. Really broke it down.
Like having an instant code review or documentation helper. And then translation bash to Python.
Yep, another great application they prompted. Translate this bash script into Python, and it generated the equivalent Python code to do the same file renaming task. The paper makes a good point here, though. You need to be aware of language differences.
Ah, like Python's reliance on indentation.
Exactly. You can't just blindly copy-paste between languages. The LL needs to handle those syntactic differences, and you need to check it.
Makes sense. And the final coding example was debugging. They gave it broken code.
That's right. They deliberately introduced an error into the Python script, used a function name that doesn't exist, like toUpperCase instead of Python's upper.
Okay. Classic mistake.
Ran the broken script, got the standard Python name error message. Then they fed both the broken code and the error message back to the LLM. The prompt was something like, This code produces the following error. Find the problem and suggest improvements.
And could it find the bug?
It did. It correctly identified the name error, pointed out that to uppercase wasn't right, and suggested using the correct Python method, upper.
Nice.
But it didn't stop there. It also suggested other improvements, like, hey, you should probably handle file names with spaces, or what about different file extensions? And even suggested adding a try dot, except block for better error handling in general.
Wow, so it went beyond just fixing the immediate bug and gave advice on writing better, more robust code.
Exactly, like a helpful senior developer doing a code review. It really shows the potential across that whole development cycle.
Absolutely. Okay, so we've seen how to prompt for different things. But how do we write good prompts? The paper covered best practices, right?
Oh yeah, a big section on that. These are the tips and tricks to really get the most out of your prompts. Kind of the art and science of it.
Okay, lay them on us. What are the key takeaways for writing effective prompts?
Top of the list. Use clear instructions. Be unambiguous. Tell it exactly what you want. Don't be vague.
Sound obvious, but probably easy to mess up.
It is. Then, provide relevant examples. We talked about one-shot and few-shot. The paper really hammers this home. Examples are powerful for showing the format, the style, the tone you need. It's like teaching by showing.
Right. Show, don't just tell.
And along those lines, specify desired output formats. If you need structured data, tell it. The paper specifically mentions asking for JSON.
Ah, JSON. Why JSON?
Because it's machine readable, easy to parse in other programs. Plus, the paper suggests forcing it into a structure like JSON can actually help reduce hallucinations, make it less likely to invent stuff.
Interesting. Okay, so be clear, give examples, specify the format. What else?
Iterative design. Don't expect the first prompt to be perfect.
Yeah, makes sense. Trial and error.
Exactly. You write a prompt, see the output, analyze it, tweak the prompt, try again. It's a refinement process.
Okay.
Closely related is adjusting the sampling parameters. Temperature, top K, top P.
Right, the randomness controls.
Yeah, temperature controls the randomness level. Top K and top P limit the choices the model considers for the next word, basically. Tuning these helps you balance creativity versus predictability or coherence.
So lower temperature for factual answers, maybe higher for creative writing.
Generally, yeah. The paper gives some starting points, and it mentions these parameters can also influence that annoying repetition loop bug where the model gets stuck.
Yes, the infinite loop of doom. Good to know there are knobs to potentially fix that. Any other big best practices?
Use instructions over constraints, meaning tell it what to do rather than listing a bunch of things not to do. It's usually more effective.
Focus on the positive. Got it.
Also, control the max token length for the output. Helps manage costs, and can also prevent runaway responses or repetition loops.
Okay.
Using variables in prompts makes them reusable and flexible. Experimenting with different input formats and writing styles, even tone, like being slightly confrontational sometimes, can surprisingly yield better results.
Interesting.
And for classification tasks using few-shot, mix up the classes in the examples. Don't just show all of type A, then all of type B. Interleave them.
Good tip. Keep it on its toes.
A few more key ones. Remember to adapt to model updates. These things change. What worked yesterday might need tweaking tomorrow.
Right. Continuous learning.
Experiment with output formats, like using JSON schema validation or repair techniques. Collaborate with others, share what works, and document your prompts. Keep track of your experiments.
Yeah, so you don't reinvent the wheel.
Exactly. And maybe the most important one underlying all of this, design with simplicity.
Keep it simple.
Be concise, be clear. Avoid jargon or overly complex sentences in your prompt. The paper uses a travel guide example, shows how a straightforward, action-oriented prompt works way better than a rambling, ambiguous one.
Excellent summary. It's clear there's a real craft to this.
Yeah.
Now, the paper didn't just look at the present, it glanced ahead too, right? Emerging trends.
It did, yeah. Always interesting to see where things might be going.
What stood out?
One really fascinating trend is automated prompt generation. Using AI to write prompts for AI.
Whoa. AI prompting itself. How does it even work?
They call it APE, Automatic Prompt Engineering. The basic idea, as the paper outlines it, is you get an LLM to generate lots of candidate prompts for a specific task.
Okay.
Then you automatically evaluate how well each of those generated prompts performs using some predefined metrics. Maybe you run them against a test data set.
Yeah.
And then you just select the prompt that scored the best. The AI finds the optimal way to ask itself the question.
That's wild. So the AI is figuring out how to talk to itself more effectively than we can sometimes.
Potentially, yeah. The paper gives an example of training a chatbot for a P-shirt website using this method.
Mind-bending stuff. Okay, what other trends?
Another big one is the integration of multimodal inputs.
Multimodal,
Yeah.
meaning different types of data.
Exactly. Right now, most prompting is text in, text out. But the future is likely about combining text with images, audio, maybe video, as inputs to guide the LLM.
So you can show it a picture and ask questions about it.
Yeah, or give it audio instructions. It's still developing, the paper notes, but it's a huge area of research, opens up way more possibility.
Definitely. Anything else on the horizon?
Just a brief mention of efforts to standardize prompts. As the field grows, it would be helpful if prompts worked more consistently across different LLM models.
Oh, yeah. That would be nice. Not having to learn a whole new dialect for each model.
Exactly. So there's work happening towards maybe finding some common ground or standards.
Well, this has been incredibly illuminating, a really thorough deep dive into that Google paper. Let's maybe try and wrap up the key takeaways for listeners.
Sounds good. I mean, the main thing is prompt engineering. It's not just hype. It's a really crucial skill, and it's evolving fast.
Absolutely.
And this white paper from Lee Boonstra, it's a fantastic guide, covers the A to Z, really the basics, the advanced techniques, code gen, best practices, super valuable resource.
And hopefully, walking through it like this has sparked some ideas, maybe a few aha moments for people listening.
Yeah.
Because mastering this stuff, it really does seem to unlock what these LLMs can do. You know, whether it's creative writing, complex problem solving, coding, so much potential there.
Definitely. If you're trying to get an LLM to write marketing copy or debug some code or summarize research papers, these techniques are your toolkit.
So the message is experiment.
Totally. Give these techniques a try. Play around with prompts and maybe check out those Google Cloud resources the paper mentions.
Right, there was an article, Prompt Engineering for AI Guide.
Yeah, it links to a free training course, more documentation, even sample prompts to get you started. Worth looking up.
We'll make sure that's accessible. Okay, so final thought to leave people with.
Well, as these AI models get woven deeper into, well, everything, how important will our ability to talk to them effectively become, using these well-crafted prompts? How will that change how we interact with tech, how we find information, even how we solve problems?
That's a big question. The quality of our prompts shaping the quality of our future interactions with AI. Fascinating stuff to think about.